I will explain to you. You will find. When we were doing the experiment just now. Usually when we are doing layer 2 VLAN experiments. We all prefer to put it on the same network segment. Because it's easier to say. Let everyone intuitively see some of its corresponding problems. But in fact we are working in real. Different VLANs will be divided into different network segments. I give a simple example. If you want to exchange visits between different VLANs, we first need to use the 3-tier function. That is routing. Because on the second floor we only check the MAC address table. We just looked at the MAC address table. VLAN ID, interface, and MAC address. They are indispensable. As long as the VLAN is unreachable. Absolutely no access to the second floor. So the second floor can't move. Only 3 floors. If it is a 3-tier routing, then everyone should know. For example, I divide host A into VLAN 10. Assign host B to VLAN 20. And they are both on the same network segment. You have to think about a question. If the same network segment, it wants to access a device like this. It sends an ARP broadcast request. Directly request the other party's MAC. Then it is impossible to communicate directly. Because it now sends the broadcast. Will not reach this device. That is to say, is unable to communicate. I can't get through the second floor. When you are encapsulating data, you will let this PC directly access. Request its MAC. Then you can't go. Because the data cannot come through. Request if the data is not available. Unable to encapsulate MAC. So if it is across VLAN, you are also configured to the same network segment. It can't communicate. We only have one way now. We go 3 floors. Access between 2 PCs across network segments. You have to configure the gateway for them. Often routers forward across network segments. It is impossible for you to configure the same gateway address for 2 devices. That is, if 2 devices are in the same network segment, gateway cannot be configured. So, we forward data across network segments. It is often configured as different network segments. For different VLANs, you have to walk 3 floors. You let this data request the gateway's MAC. Data must first reach the gateway to check the routing table. So we are on the project. Usually it will be divided into different VLANs and divide into different network segments. This is the gap between our experiments and real applications. The above mentioned is a physical connection per VLAN. When you learn NP in the future, you will talk about ARP proxy. In the future, there will be an ARP proxy in the VLAN. We only learned one ARP proxy in the NA phase. Is the easiest one. Then you will know that there are other ways to achieve. Let's look down. Let's go on to talk about a slightly more complicated knowledge point. One-arm routing. The difference between the single arm and the picture just now is that there are 2 lines in this graph. This picture has only 1 line. 1 physical connection per VLAN. It is called a line for each VLAN connected to the router. This has a router interface. One-arm routing refers to the. This is only one to undertake the traffic of multiple VLANs. In the future, there will be more than just these 2 flows. Can be VLAN 4 or VLAN 5. Can connect. Then all go this line. Single arm with only 1 line. Let's talk about how it's done. There is a trunk written here in the middle of it. Different from before. Just here is access. Now is the trunk. So the configuration of the trunk is demonstrated here. I just told you. The interface of the router is a layer 3 interface. It doesn't recognize anything about the tag. If configured as trunk here, Trunk is released for data. Then when the data is sent, if their current native VLANs are different, it may be posted with a tag. Now this interface is not recognized, so it creates some problems. Everyone should know. The interface of the router is a layer 3 interface. It cannot configure layer 2 VLAN. Therefore, the layer 3 interface does not recognize the tag by default. It has no way to receive and forward data. But one such implementation is shown in the figure. That means it will definitely come true. The interface of the router does not recognize the tag. I want it to recognize. At this time, the physical interface of the router is not working. We can make a logical interface for it. Then I can, based on a physical interface, give it a few logical subinterfaces. For subinterfaces, I can, under a physical interface, based on it has many subinterfaces, let these subinterfaces serve different VLANs. Like this picture. 2 interfaces on 2 routers. We now let an interface of a router use as 2 subinterfaces. What are the characteristics of this subinterface? First, it can configure the IP address normally. To us, the host has to configure the gateway. Configured on subinterfaces, it can be configured with IP normally. Secondly, this subinterface can also have layer 2 functions. That is, it can handle tags. Now means that only one line in the middle will be able to complete. Trunk can be done between them. Let me briefly talk about the function of the subinterface. It now receives a data. This is the access interface. Tag 2 here. Through this router. We then proceed to the trunk interface. Suppose its native VLAN is 1. Came out 2. Then when carrying such data with tag 2, when entering this subinterface, the subinterface can receive tagged data and strip the tag. It has the ability. Simultaneously, another subinterface can process the data of VLAN 3. That is, it now looks up the table. It now goes from segment 2.0 to segment 3.0. After checking the local is a direct route to come out from another subinterface. When it comes out, add another subinterface VLAN. Is tag 3. Then send. Pass through the trunk interface of the switch. Then when passing through this access interface, strip off the tag. Then forward to host B. Complete the communication between the two of them. Is equivalent to. We extended this interface to it. In this way, the problem of insufficient router interfaces can be alleviated. But in this case, it will have some other problems. We have another way. Layer 3 switching. Well, first you need to know. There are actually a lot of problems with one-arm routing. So it's not very common in corporate networks. May be seen in small businesses. Medium and large enterprises do not use it for a long time. Because it's very unoptimized. Including many switches now. In fact, it's all 3 layers of switching. So now one-arm routing is rarely practical. But we have to learn it. This knowledge is very important. First, its first question. Single point of failure. That is to say, once this thread is broken, you will find all business is now closed. This is still 2 VLANs. Both VLAN 4 and VLAN 5 can be connected to the switch. Then between all these VLANs, all visits to be made follow this line. If this thread is broken, it will not leave. This is the most important question. Single point of failure. Second, for the router, it will have additional performance loss. The main function of a router is to responsible for IP addressing and forwarding. This is in terms of 3 layers. Address forwarding is a router in itself. This processing tag. This is not someone's job. So where are you now? For our router, configure the function of the second layer on it. Then there will be some additional loss on it. This is the second point. And a third point. This link will have certain congestion problems. That is, the current communication traffic between VLAN 2 and VLAN 3. Go this way. In the future, if you access other VLANs, you will not take this route. There will be a lot of traffic on this road. Been piled on this one line. This is pretty much the same as the single point of failure problem. Interaction between all traffic. All follow this line. It is not optimized. So one-arm routing will have such a problem. So how to solve it?